Hello, and welcome to the explainer video for Darkpool, a mobile App Store chart rankings intelligence tool published by Mobile Dev Memo. What are mobile App Store chart rankings? Both Google Play on Android and the App Store on iOS keep track of relative chart ranks for all of the apps on their platforms. These rankings are available for downloaded and grossing ranks, where grossing relates to the amount of money generated by these apps by in-app purchases and subscriptions, and downloaded relates to the number of app installs they have generated. These rankings are relative, meaning that they don't convey any information about the absolute volume of installs or absolute amount of revenue an app generates, but they do provide some information about any app's performance relative to other apps and whether those values, installs and revenue, are changing over time. Note that the logic used to determine the rankings is not public, and both app stores may take aspects like velocity into account when ranking an app. Nonetheless, because this data is published by the platforms themselves, it is reliable. The Darkpool platform collects this data on a daily basis and makes it available through the MDM Pro subscription to be queried. In this video, I'll explain how to use Darkpool's chart search tool to query this data to surface insights. Darkpool retains data across most Google Play and App Store charts on a rolling 90-day basis. First, if you want more in-depth information about how to use this tool, you can simply click the How Does This Work button at the top of the Darkpool chart search to understand query structure, the reserved keywords that are available for use, the aggregate functions that are available for use, and to find some sample queries. I'll start the video with a very simple query to pull all apps in the iOS Games chart for the top grossing chart type in the UK App Store where the most recent rank was less than or equal to 30. This is the query. The chart type column here refers to either top downloaded or top grossing, and the chart category column here refers to the specific category of app that is being queried, with examples on iOS being games, including games subcategories, health and fitness, productivity, business, etc. In this case, I'm using the iOS grossing and iOS games reserved keywords for chart type and chart category respectively, which is why those values are not in quotes. If you wanted to query from a chart type or chart category that doesn't have an associated reserved keyword, you'd look those values up from the How Does This Work console and place them in quotes in the query. Note that only the select statement is available for use in Darkpool, and the table selected from should always be specified as Darkpool in all lowercase characters. One other thing to note here is that the wildcard character is used in the select statement. The purpose of Darkpool Chart Explorer is to query chart rankings by day. The back end of Darkpool Chart Explorer tokenizes the query and transforms it into a format that can query the relevant data, but you can think of the Darkpool system like a table with dates for columns, dimensionalized by chart type and chart category. Selecting the wildcard character selects all date data from the system, which is 90 days worth. Instead of the wildcard character, I could explicitly select the 90 days keyword, which merely selects all 90 days worth of data. There are other reserved keywords related to timelines, such as 3 days, which is the last 3 days worth of data, or 7 days, which is the last 7 days worth of data, or prev 3 days, which is the 3 days worth of data prior to the most recent 3 days worth of data. But you can discover all of these keywords in the How Does This Work console. You'll note that the query restricts the last day value, which is simply the most recent daily rank, to less than or equal to 30, which relates to ranks 1 through 30. The query also orders the results by last day, which again is the most recent rank, in an ascending fashion, which means the lowest rank, rank 1, will be first, followed by rank 2, rank 3, etc. Pressing Submit Query here queries the data and returns a table of the values. I can scroll through the data here to observe it. But I can also graph the data by pressing the Graph Results button at the bottom. Pressing the button brings up some options. Since this is a data series, the chart type is automatically set to line. I'll want to invert the y-axis to have ranks 1, the best rank, be rendered at the top. I can change the title here to UK Current Top 30 Grossing Games Last 90 Days. and then graph the chart. This chart is a little busy, so I might change the limit to the top 10 and graph that. Again, this is a fairly simple query that shows me how the current top grossing games in the UK have evolved over the last 90 days. What if I wanted to see the average rank of the top 10 grossing games in the UK on iOS? I could simply use the average aggregate function. Note that I can't use the wildcard operator in the aggregate function and have to specify a date range. I'll use the 90 days reserved keyword, but I could use any other reserved keyword or type the specific dates that I care about by hand. When I do this, it provides the average ranking of the current top 10 grossing games in the UK iOS App Store. This is not a series, so when I graph it, I'll choose bar chart. I could also find the minimum or maximum ranking values for these apps using the best rank and worst rank aggregate functions. The last query looked at multiple apps based on their rankings. If I wanted to isolate a single app across all of the geographic storefronts in which it is available, I'd do something like this. In this query, I select the 90-day chart ranking values of the ChatGPT app across all geographic stores in which it is published on iOS for the top downloaded chart overall. Note the use of the iOS overall reserved keyword, which represents the overall chart, which covers all categories except gaming. Note also that I've redefined the name column to be the concatenation of the app's name and the relevant country for that row so that I can distinguish the various countries in the chart. You never have to specify the name column in the select statement unless you redefine it. Name, chart category, chart type, country, developer, and app ID are always included in query results. Here I can see the ChatGPT chart ranking across all of the geographies in which it is available on iOS, ordered by the last day of ranking. But what if I wanted to see the top downloaded overall chart rankings across both iOS and Android? I'd alter these two last conditions in the where clause. I change the chart type clause to be in iOS downloaded, Android downloaded. And the chart category clause to be in iOS overall, Android overall. Note once again that reserved keywords should not be enclosed within quotation marks. These reserved keywords map to the relevant chart types and chart categories for these classes of charts on both iOS and Android. Note that I don't provide an explicit result limit in this query with a limit clause, meaning I don't restrict the number of rows that will be returned. In the case where no limit clause is provided, a limit of 100 results is automatically applied. I'll need to change the concatenation function for the name column here to add platform, which is iOS or Android, chart type, and chart category. I'll continue to order by the last day ascending, meaning the best ranks are at the top of the table. This would be a very busy chart if I graphed it. So I'll apply a limit of 10 to the result set. What that means is that I'm selecting 90 days worth of chart data for the ChatGPT app on the top downloaded overall charts on both iOS and Android across all geographic stores in which it is published. This last query is more complex. What I'm doing here is selecting the best rank and the worst rank from the dataset in the US for the iOS downloaded chart in the iOS overall chart category, where the app's worst rank over the past 90 days was greater than 20, and its best rank over the last 7 days was less than 10. This will showcase the apps that have seen their 7-day rankings improve the most against some 90-day low point. Because the query includes both a series, which is the 90 days column, and categorical data points, which are the best rank and worst rank aggregate functions, I could graph this as either a line graph or a bar or scatter graph. In this case, I'll graph it as a line graph. I could also take the average rank over the past 7 days and not the best rank, which could be volatile, and select for that by changing the best rank aggregate function to average. This time, I'll use a bar chart. Whenever you graph a bar chart or a scatter chart, the colors used for each value are randomly selected. If you don't like the colors, you can simply recreate the graph. I could also calculate the size of the rank jumps by subtracting best rank from worst rank. I'll order the rank jump descending because in this case, a larger rank jump is better than a smaller rank jump, and use the bar chart again. I hope this helps to explain how the Darkpool Chart Explorer works and the various use cases for it. If you're familiar with SQL, you should have no problem intuitively understanding query formatting in Darkpool. If you have a subscription to MDM Pro, this tool is free to use at mobiledevmemo.com/Darkpool.